Well, I believe this is part 6, and the information I'm going to show you came out of an RCA tube manual, one of my RCA tube manuals that I've got. This is actually relatively old, but even the newer manuals has got the same thing. Might have just some slightly different tubes. This is resistance coupled amplifiers is what this talks about, and mostly they're voltage amplifiers. This is some of the listing of the tubes that they'll be using or talking about that are listed in this. And what this is actually it's going to have some charts that's going to give you information as far as your load resistors, your grid load resistor, your plate load resistor, your coupling capacitor, when possible the cathode resistor and its bypass capacitor, and so on, for both triodes and pentode tubes, including some pentode tubes that are directly heated cathodes, or where the filament itself is the cathode. Now, they have a bunch of reading. They talk about the suitable tubes. If you don't have a tube manual, you can download these tube manuals. There's a couple, 3 sites online. I think the very first video I put up, I put some sites where you can get some stuff like that. And it's good reading. It talks about resistance coupled amplifiers and everything. They go over their symbology. This changes over the years. There's slight difference, only a couple symbols of what I've showed you. They use RP, capital R sub P, as plate resistor, which is what your load resistor is for the plate. And that's the same thing as R sub L. The blocking capacitor, coupling capacitor, they just list as C. I put CC for coupling capacitor. They talk about frequency response, and then they go into the basic circuit that they'll be talking about, that they're designing, or the numbers follow to. This is a triode amplifier. They go into the pentode filament style amplifier here, show you where all the resistors hook and everything. The indirectly heated cathode pentode amplifier, and even some phase inverters, which we haven't went over yet. Now, basically what this is, I printed off just a couple sheets, just some basic stuff, some of the low voltage tubes. And what it is they'll list you 3 voltages for EBB, or your B plus voltage, 45, 90, or 135. These are your 1L4, 1S5, 1U5, 1U4. So these are all like battery operated set tubes, or tubes of that nature. You get into your others like 6S8, 6SQ, or 6SQ7s and stuff. You'll see that we have a little bit higher B plus voltages listed. But what you actually do with this is you can take any line, depending on what voltage you want to use. If you're going to have like a 90 volt on a 1L4, then you can see 3 different means, 3 different plate load resistors, R sub L or R sub P as they call it, your grid resistors, which are your grid load resistors. These values are in megohms. So this is 0.22 megohms here, which is 220K. Same here, this would be 470K, 1 megohm resistor. A 1L4 happens to be a pentode, so it has a screen grid, which will be listed as, for the resistor for it, RG2. So on RG2, they'll have your various different resistance values, again in megohms. Now on this tube, they're not going to use a cathode resistor. They have the grid to bypass or decoupling capacitor values, which we follow along. These will be in microfarads, and you basically pick something as close as possible. Since we don't have a cathode resistor, then we don't have to have a cathode capacitor or coupling capacitor between stages, again in microfarads, will be listed here in the various different ranges. Voltage output is here, and then you got your voltage gain right here. So basically what you do is you pick out some parameters that you want to work with, and you establish what B plus you're going to have, a 45 volts, 90, or 135 over here, or whatever kind of tube it is. It could be higher than this depending on the tube. And then the other thing you want to look at is you're going to determine exactly what kind of voltage gain you want, and then from there you can just pick your parts. Now on, which evidently, yeah, I did. Some of them, like I say, will have a cathode resistor, so that if it's being self-biased that way, like right here, we have our resistance here. Now the cathode resistance is in ohms, so you see 10,000 ohms, that's a 10K resistor. So these will be in ohms, these values. And again, the cathode capacitor bypassed, again in microfarads, coupling in microfarads, and then voltage output and our voltage gains. So, and this is actually how it's mostly done. The engineers back in the day actually followed these charts as best they could. There was always some design changes and certain things they might be able to not get. Some stuff might cost more than other stuff. I need to talk a little bit about this too. Whether it was something happening today in design or say the 1940s, engineers were not given free hand, nor are they today. Stuff is designed by committee. So, this is nice stuff, and it is generally followed. Because basically this is wrote by the guys who built and designed the tubes. So who better to know how those tubes are going to operate than the guys who built them and designed them. So, and every one of these circuits have been tested. But that don't always work out in the real world. In the real world, we design by committee. And what that means is you have the engineer who's doing the design, or the head engineer. It might be a head engineer. It might be a large thing that they're designing with several engineers. But he'll be at a table. But you got someone from manufacturing, the head of manufacturing, that will be there to list out whether or not, how easy something is to build, how easy it is to put together, how easy it is to maybe even get the parts to do it, the tooling, the whole 9 yards, the whole entire manufacturing. So they've got to have that input. You have someone there, you'll have someone there from marketing. Someone head of marketing that's going to be sitting there going, well, if we advertise this to do this, this, and this, we can probably sell it better than if we just say it does this and that. And then you may have some other design team people that are more cosmetic designs or things like that. Say in a radio, these old radios, you'd probably definitely also have the cabinet design and stuff. So that's going to make a difference about the size of chassis, the size of speaker, and everything. Then you're going to have management. And management's primary goal is to look at the bottom line. And they're going to want to know, if we build it for this price, can we sell it for a price that we can make a decent profit? And that's all they care about. So sometimes, as much as this information is nice, you may work on a radio or look at a radio and see some of the things that are not quite the same as might be in here. They may be using a particular tube that's listed here, but maybe it's not quite the same voltages or not quite the same values. It's not that they wanted to go outside this or the engineers did. It's just that parts availability, cost, the whole 9 yards had to go into this before the final decision and the final design was put down. And everybody had to be happy, including and especially management, because they're concerned about the bottom line. But this will be very close. And you could design something using this information and it will work. And this is the starting point, and this is where engineers always started from. To this day, they do the same thing. They use data sheets now. They call them data sheets instead of like tube manuals or anything like that. But they do the same thing. They start from a point of those data sheets because that tells you everything they need to know about whatever that part is and what it can do and how to hook it up. And it'll have stuff like this, a modern day version, but showing how the basic circuit is hooked up and everything. So get some tube manuals. You'll need them anyway if you don't already have them. And like I say, you can download them free. I look back at my first video in the description. I listed some places to get them. This information is in the back. Read it. It's a good read. There's other information in the front of the book. It talks how tubes are made, the materials they use to make them, and so on. Plus, along with a lot of stuff I've been talking about, but more in depth, dealing with design of tubes, how they're designed, or how the circuits are designed, load lines, and all this stuff. Now, that's basically it on voltage amplifiers. Now the next thing would be, continuing on, would be power amplifiers. Power amplifiers basically differ. Voltage amplifiers amplify voltage. Power amplifiers are concerned with current amplification. That's your output tube, or output tubes that feed the speaker. So I need from you guys, though, to know something. I've noticed the viewer doesn't look so good, the viewers as I go along in this tube theory. If you really want me to continue in this and not go doing something else, just let me know. I don't care if it's just one person. If I can help one person, that's good enough for me. But I just need to know that a lot of you are still interested, and if there's people still interested in wanting to learn more about this, because like I say, the next one we'll go into power amplifiers. After we get through those, then we're going to step into looking at an actual design and designing what it takes, the steps it takes to design an amp. Now I know all this really has been geared towards audio amplifiers, but IF and RF amplifiers are virtually the same thing. Some of the component values is going to be a little different because the frequencies are different, but an amplifier is an amplifier is an amplifier. Now after we get through the amplifiers, we're going to go into oscillators. Another thing, I've been thinking about it, and give me some comments on this if you think it might help you, is doing something on DC and RC circuits, or DC and AC circuits, excuse me. Primarily, the reason for that is, generally when you go to school, that's where you start. You learn DC, then AC, and then you move on into stuff like this. You know, it'd be more like transistors and stuff. But so I need to know if you guys would, you know, on DC, you know, we'll talk about series and parallel circuitry and stuff, and circuits and Kirchhoff's laws, and probably even about solving Wheatstone bridges. And then AC will be talking about inductive reactance, capacitive reactance, impedance, filters, the Q of a filter, and so forth and so on. So if you think that would be good, something that you would like, just let me know. If not, we'll just keep moving on. So I thank you for watching. I really appreciate the comments. So until the next time, thank you.